Okay, so for the machine vision task today, we are going to classify image using convolutional neural network. Now, we have prepared a dataset that is given here. Is it's a it's an X-ray images of patients with who are tested for either being negative or positive of COVID-19. So we have to test and train the dataset. So in the training set, it's where we have two classes, right? The one who is tested for being positive and negative. And in training dataset, it's where the neural network are trying to learn the image. And in testing set, it actually has images with the same as training dataset, and it helps in validating the neural network. And so now we are trying to code this. So the first thing to do is import library, all the libraries including Keras and NumPy. And after that, we try to initialize the CNN. So in here we have a classifier equals to sequential. Now the first step is convolution. So in here is a convolution layer. We add conv2d, and here's where we extract features from the images. We have 32 features with the size of 3 times 3 matrix, and the input shape is 64, 64 and 3, and we add an activation functions which is relu, and the second step is pooling. So we add max pooling 2D. So pooling is where data has to be reduced because it has data that we really do not need, and we set the pool size in 2 times 2. The third step is flattening. So we add a flattening layer. It's where we flatten a 2D image to 1D image. And the next one is the full connection. So we add these layers. The first one is dense. We set it into 128 units or nodes. We input this to a hidden layer, and we add another activation function which is relu, and then add a dropout layer. So next one is we add another dense layer, but we set it into one because the 128 input we connect it into one output. But in this one we add another excavation function, but a different one, which is sigmoid. Now here's the part where we compile the CNN. So classifier.compile, we have an optimizer is Adam, loss is binary cross entropy, and the metrics is accuracy. So the next step after we initialize the convolutional neural network, we fit the CNN to images. The first step is train datagen. So in here we generate a data that needs to be given to a neural network, but it's the training set. So we have rescale, shear, and zoom image, and horizontal flip. And the next one is test data gen. In here we only set a rescale. Now the next thing to do is we process the data. The first one is training set. So we have the train data gen in here where we generate data, and the directory is the training set, which is COVID-19 and then we set the target size into 64 and 64, and batch size is 32. So batch size is where how many pictures, so we have 32, right? It's how many pictures do we need in one iteration, and we set the class mode into binary, and the same thing goes with testing set, but we have a different directory. Now the next thing to do is we train the model. So we generate all this data here into a CNN and execute the neural network. So as we can see, we have set the steps per epoch into 100, and we set the epochs into 5, and then the validation data is the test set, and the validation steps is 10. So when we have the greater value of epoch, it will also, so when we set a larger number of epoch, it will generate a greater accuracy value when we train the data. So, and then the last step is where we make the prediction. So in here we have test image is where we load an image. For an example, we have this given image of an X-ray image with the one who is tested for being positive, and in here we test if it's working or not, if their neural network is working or not, and then This we convert the image to an array. So basically these statements is actually converting one image into a numpy array. And here we predict image that is stored in the testing set. And the last one, if the result is equal to 1, then the prediction would be positive, else it will be negative. Now we will try to run the code. So in here you can see that I forget to mention that we are using a TensorFlow environment from Anaconda. Because I have set the epoch into 5, so it's so now we are done with testing the data with 5 epoch, and as you can see, the accuracy value keeps increasing, and the result matches with the given image, which is positive. Now we're trying to test if the input image is negative. So we try with one of these pictures. Now the given image will be a patient who is tested for being negative. We assume it's from that's it. And now we will try to run the code. So now we are done with predicting the negative images. So it's the same as the previous one. We have I put 5 as the epoch value, and the accuracy value, as you can see, is increasing, and the result is it matches with the given input, which is negative. So I think that concludes to how we classify images with convolutional neural network. Okay, thank you.